Hey Year 12 and welcome to the next episode of Mathematical Mowbray Movies. We're continuing on with our work on trigonometry and we're not looking at right angle triangles, we're looking at wrong angle triangles, better known or more mathematically correctly known as obtuse angle triangles. So as I said in the last video, sorry about that corny joke, I don't know how long it will last. As I said in the last video, there's two rules that we're going to be using for calculations with obtuse angle triangles. So the first rule is this rule here, the sine rule, and the second rule is what we call the cosine rule. This video is not going to deal at all with the cosine rule, it's only going to look at the sine rule. So let's get into what this particular rule means and how we use it. So we use the sine rule when we are given or interested in calculating and working with two angle side pairs. So what do I mean by an angle side pair? On your formula sheet you're given a formula that looks like this. It says in triangle ABC, A over sine A equals B over sine B equals C over sine C. What's that rule actually saying? Well, it's saying if you've got a triangle that's labelled ABC, the capital letters refer to the angles, and you can see that because they come after the sines, sine A, B and C. It says that the side opposite each of those angles, so the matching side opposite, the ratio of that side to the sine of the angle is equal in each of the pairings. So let me explain that a little bit more and label this diagram to hopefully help. If this is angle A, then the side that is side A is the side opposite angle A. So that's that side there. If this is the angle B, the side or the pair for angle B is the one directly opposite, so this side here. And if this is angle C, the pairing side for angle C would be this one here. So what this rule is saying is that the ratio of each of those sides to their pairing angle, or the sine of their pairing angle, is equal. Seems a little bit crazy and you're thinking, how are we going to use this at the moment? But we will. I just want to make a little note. In the formula sheet, they give it to you in this format, and you can see that on the top is each of my sides, A, B and C. So these each refer to the sides, and you're going to use this formula when you're trying to calculate a side because you want the side to be on the top. When you're trying to calculate an angle, so that is one of the A, B or C that follows the sine, you're actually going to use a flipped version of the rule. So instead of having the sine on the bottom, you're going to have the sine on the top. Instead of having the sides on the bottom, you're going to have the sides on the top, you're going to have the sides on the bottom. I'm getting myself all mixed around there. So this is what you're going to use if you're trying to calculate the angles. So as a general rule of thumb, if you're trying to calculate the sides, you want the sides on the top. If you're trying to calculate an angle, you want the angles to be on the top. That's really what this is saying. Okay, I know this rule doesn't look like the most straightforward to use, so let's actually have a go at using it and then it will hopefully make a bit more sense. I've just done up this little set of steps that we're going to follow to use the sine rule. So I'm going to show you as we go through on a particular example so it makes a bit more sense. So the first thing to do when you're using the sine rule, and first of all obviously you've got to identify that you're using it because you've got two angles and two sides. But then you need to identify if you're trying to calculate an angle or a side. So here's my example here. In this case, I'm trying to calculate a side. So that's the first step, and it's a pretty straightforward one. I'm trying to calculate a side here. Step number 2 says write out the rule. Now, because I'm trying to calculate a side, I'm going to want to have the sides on the top. So remember, that means I need to have the little letters written on the top. That text is a bit thick. The sides on the top. So I'm going to write my rule out as A over sine A equals B over sine B. We don't actually need the C over sine C, so you can just leave it at just those two pairs. So I've written out my rule and I've made sure that because I was calculating a side, I had the sides on the top. Step number 3 says identify the angle side pairs using arrows. So I'm going to use my arrows to identify what the pairs are. You always start your arrow at the angle and draw directly across. So the side that pairs with my 120 is this one. The side that pairs with my 30 is this one here. So I've identified my angle side pairs using arrows. Step number 4 then says substitute. It says make sure the unknown is top left. So I'm trying to find this x here. So I'm going to substitute these different angles and these different sides into this formula, keeping together the pairs. X and 120 is a pair. I want my unknown to be the top left. So I'm going to substitute my x in place of a. Now underneath that I need to have the pairing angle. So I've got to put sine 120 here. Now I set up my other one. B refers to my 8, it's a side. And I need sine 30, the pairing angle, to be underneath. Now this bit, lots of people screw up because they get the numbers in the wrong spots. Remember that the angles are after the sines, and remember that you've got to pair them together. Then the last step here says solve. Well, that sounds easier said than done, doesn't it? I'm trying to calculate my x. At the moment I've got divide by 120 here. So if I'm trying to bring that over, I'm going to need to times by sine 120. So this is going to become x equals 8 times sine 120 over sine 30. That's going to give me my x. So I'll plug that into my formula, into my calculator. There we go. 8 times sine 120 divided by, and if you guys have got your fraction button, you'll do all of that, sine 30 gives me 13.86. So this tells me that in this triangle, x is actually 13.86. Okay? Let's have a look at a second example and we'll go through the steps again. Here's my second example. So I'm going to go through the same process. First of all, I've already identified I need to use the sine rule because I've got 2 sides and 2 angles. Now I've got to identify if I'm calculating an angle or a side. Here's what I'm calculating. This is an angle. So I'm trying to calculate theta, an angle. So when I write out the rule, I'm going to write it out with sine A on the top this time because I'm trying to calculate an angle. Step number 3 says identify the angle side pairs using arrows. So I'm going to do that process. Theta, which side pairs with theta? It's the one directly across. 20, which side pairs with 20? It's the one directly across. So I've identified my pairings. The next step then says substitute. Again, it reminds me to make sure the unknown is top left. Well, here my unknown is theta. So I'm going to put theta on the top left as my unknown, sine of theta. Remember, it's always the angle. I need to put the pairing side. Which side pairs with theta or sine of theta? It is the 12, so it's going to be over 12. Then over here, I put sine of B, so that's my other angle, so sine of 20. And the side that's opposite is 6. So again, I've set this up. Then the last step, of course, says solve, which makes it sound easier than it perhaps is. This here is divide by 12, so I'm going to bring this up and multiply by 12. So I'm going to get sine theta equals 12 times sine 20 divided by 6. So I plug that into my calculator. 12 times sine 20 divided by 6. So I get 0.68 there. Now remember, at the moment this is still sine theta, and of course I need to get theta. So I just do that the normal way. I take the inverse sine of 0.68. Move him out of the way. So the inverse sine of 0.68, I really shouldn't have got rid of my number before, should I? There it is. So I want the inverse sine of that answer. And I'm going to press equals. So it gives me 43 degrees. I'm just going to round it to the nearest. I'll put it into 43 degrees, and let's say it rounds to 10 minutes. Now here's where our work on the obtuse angles comes into play. I've got an angle here that's 43 degrees and 10 minutes, but I can see from my triangle that this angle is actually an obtuse angle. And so it's not actually 43 degrees and 10 minutes, it's actually the one that is 180 minus 43 degrees and 10 minutes. So I need to make sure I do that on my calculator. 180 minus 43 degrees and 10 minutes. So you can see that that gives me 136 degrees and 50 minutes. So this is where that work comes into play. So using the obtuse angle work that we'd used before in the last video. Okay, so you can see there's a few little bits and pieces going on in these questions. So remember, the steps are that you need to follow are those ones that we went through, and so it's now going to be your turn to have a go at this question. As I said, a little bit tricky, so I'm going to put this here and get you to have a go at calculating, I'll get you to do this one first. So the first one is to calculate x in this case. Alright, how did you go with that question? I'm going to go through it and see how you went. So the first step, am I trying to calculate an angle or side? I'm calculating a side. So I write out the rule. I write it out in the way where I have the A on the top, the B on the top, so that I've got my sides on the top. Then identify the angle side pairs. This is the one opposite, and this is the one opposite. So I've got my pairings there. I substitute in, making sure the unknown is on the top left. My unknown was my x, so I write x over here. The angle pairing with x is sine 15. I write my b, my other side at the top, and the angle pairing with it, which is 110. My last step then is to solve. I need to move this sine, divide by sine 15 up by multiplying. And I end up with x equals 15 times sine 15 divided by sine 110. Again on my calculator, 15 times sine 15 divided by sine 110 gives me, in this case, 4.13. So that's the length of my side, 4.13. Alright, the next one for you to have a go at, hopefully you went alright with that one, is this one here. This time you're calculating an angle. I'll put these instructions here again for you, so give that one a go. Alright, hopefully you went alright with that one. I'll just go through it and see how you've gone with it. This time, again, I know I'm using the sine rule because I've got two sides and two pairs. Two sides and two angles. I have to decide if I'm calculating an angle or a side. Well, I'm trying to calculate theta, so I'm trying to calculate an angle. So I'm going to write my rule out as sine of A over A equals sine of B over B. This time putting my angle on the top because that's what I'm trying to find. Now I need to work out, now I need to work out my pairings. Here's one pairing, here's my other pairing. Then I need to substitute and make sure that my unknown is top left. I'm trying to find theta, so I'm going to write sine of theta on my top left. Sine theta is opposite the 9, that goes underneath. Then I need my other angle and side pair, so I put sine of 30 over the side that it pairs with is 7. I'm trying to find sine theta, so I need to get rid of divide by 9 by moving it up and multiplying. So I get sine theta equals 9 times sine 30 divided by 7. So again, I can plug it into my calculator, and I've got 9 times sine 30 divided by 7 equals 0.64. Okay? Then, as usual, I need to get the theta on its own, so I do the inverse sine of 0.64. Sorry, it's not ideal, but I'm going to have to move my working up here. So I do the inverse sine of that answer that I got, and I get that this is 40.000 degrees. So this is 40 degrees is my theta. Now I have to say to myself, was this an acute angle or was this an obtuse angle? In this case, it was an acute angle, so there's no further calculations to do. I can be pretty confident that that I'm correct there with the way that I've set that up. Okay, the only other thing was that you saw on this set of steps that there sometimes is an extra step. And that extra step sometimes involves calculating the third angle. So these ones are a little bit trickier. And we do this when the pairings of the sides don't work out perfectly. So I'll explain what I mean here. In this triangle, I can see that this is a nice pair. The 20 and the x, they pair nicely. But you can see that this isn't a pair. The 110 and the 15, they don't pair. I have no quick way of working out this side. So I have no quick way of working out the side that pairs with 110. But I can always quickly work out this angle here, the third angle, and that's what you need to be able to work with. The angles in a triangle add up to 180. The angle sum of a triangle is 180. So I can work out what this angle must be. If I know that this one's 110, and I know that this one is 20, those two together add up to 130. So this one here must be 50, because then the three of them would add up to 180. Once I've got that, all of a sudden now my pairings work and I can proceed as normal. So in this case, I'd say I'm trying to work out a side here, so I'm going to write my rule out as A over sine A equals B over sine B. Do my substitution. X goes first and X is opposite sine 20. Do my substitution here. My B is the 15 over sine 50. Take this up. I end up with X equals 15 times sine 20 over sine 50. Plug it in on my calculator. 15 times sine 20 divided by sine 50 gives me 6.69, which I'm going to round up to 6.70, okay, as my length there. So that's one instance where I need to use that third angle before I can proceed. This is a similar situation but a slightly different one, and look, we're really talking students who are looking at like band 5s and 6s here. You've got to be able to manipulate these things and see a few steps ahead. So I look at this situation, I can see I'm trying to calculate theta. Now if I'm trying to calculate theta, I'm gonna need this side. Well, it's not easy for me to work out this side, but as I said, it is easy for me to work out this angle. So what I'm actually going to do in this particular question is, I know I've got this nice pairing, that's good. I'm actually going to first of all calculate this. Let's just call it, give it another symbol, let's just call it lambda, this little symbol. Then I've got a nice pairing here. So what I'm actually going to do here is calculate this angle, and once I know this, then I'm going to use the fact that I know these two to work this out. So it's a little bit complex here. So the first step, as I said, is that I'm going to try and calculate this lambda here. So I'm trying to calculate an angle, so I'll be using that sine A over A equals sine B over B. I'm going to substitute in what I know, or what I'm trying to work out. I'm trying to calculate this. It's over the side that's 6. I know that this is 100. So over the side, that's 12. I move this up. Oops, sine 100 times 6 divided by 12. Plug it into my calculator. Sine 100 times 6 divided by 12 gives me 0.49. Then I use my inverse sine as normal. The inverse sine of my answer, which gives me 29 degrees, or 29.49 degrees. So I'm going to say that, I'll write it all out for the moment. I'll say that this is 25.50 degrees. Okay, now once I know that this one here is 29.50 degrees, well, now I can work this out, because now I'm left with a triangle that has an angle here of 100 and an angle here of 29.50. I know that the three of them have to add up to 180, so I'm going to say this plus this gives me 129.50. So I'm going to take that away from 180 in order to get what theta must have been. So you can see that there's not sort of an absolute recipe to follow with some of these. You've got to be a little bit flexible with your knowledge. So this, if I write it in degrees, minutes and seconds, is 50 degrees and 30 minutes. Okay, so last question. This is for you to have a go at. It's a little bit of a trickier one, but as I said, some of these are a little bit trickier. So give that one a go. Okay, hopefully you went all right with that one. If you've gone all right, then well done. These ones are quite tricky. It says 3 towns are marked on the diagram, and it tells us some of these distances, and they've labelled some of them for us. They're asking us what is the distance from P to Q. So they're asking us what is this distance here. So they're asking us for a side. So straight away I know I'm going to write my rule out as A over sine A, because it's for a side, equals B over sine B. I now need to work out my pairings. This is one of these situations where I'm going to need to find x, I'm going to need the angle that's opposite it. So I'm going to need this one here. So I have to do that extra little bit of calculation work first. 26 plus 46, it's too late in the evening for me to work it out. 26 plus 46 gives me 72, and 180 take away that 72. I can probably do this one. Tells me that this angle here is 112 degrees. Oh gee, it's really bad, isn't it? 108 degrees, it's pretty late. So this is 108 degrees. So then I'm going to identify this one pairing here. Here's my other pairing across here. Then of course I do my substitution. So I substitute in my unknown at the top, sine 108, my other side at the top, my sine of 26, since that's the opposite pair. I bring it up, I rewrite it, and whack it in my calculator. Hopefully it gives me the answer that I'm after. Sine of 26 gives me 164.88 kilometres here. And they've asked me to round to the nearest kilometre, so I'm going to say that this is 165 kilometres. Okay, hopefully you went okay with all of those questions. I know some of them are a bit tricky and it might take a little bit more work, but stick with it and I'm sure you'll get there. Good luck!